Well, welcome to our new quarter. The subject that we are going to study is probability and statistics. And this is one of the most extensively used um, subject in the engineering field. Believe it or not, if you are going to work in the manufacturing industry or in maintenance or in design, whatever field of application that you choose to work on, uh, you cannot escape of this probability and statistics application. So let's make this a little bit easier and interesting along this course. You already know my name. My name is Juan Cervantes, and I'm going to be teaching you this probability and statistics subject along this period. Um, as you know, I'm going to share you the statistical tables because most of our calculations we are going to use them. And I know that many of you you don't have a laptop computer. If if you don't have it, it's not um, mandatory requirement. But if you have a laptop, it is a good idea to start looking for Minitab statistical software because at the end of this course, we are going to use this software, Minitab statistical software. Uh, I have a version that I can share with you in the Google Drive. It's the version the 18. This is the one that I have, and I have the proper license file, so you can unlock it and freely start to work on the full version of this Minitab statistical software. If you don't have it, you want it, just let me know so I can share a copy in the Google Drive and find a way to get that installed in your computer. You need some assistance, you can let me know so we can get online, especially at the end of the day, and we can have a discussion on how to install this software in your computer because you're going to use it. If you don't have a laptop, I prefer a lot to use the statistical tables and do manual calculations. And along this course, we are going to use the the specific formulas for all the problems that we are going to solve. So if you don't have the Minitab statistical software, it's not a big deal, not a big problem for you because we are going to use mostly manual calculations. But in the case that all of you have this software, we can switch from manual to software and expedite the session to get this done earlier if we can. About the how are we how we are going to grade your work during this period. Well, you already know that I work with this rubric here, and this is the same rubric that we were using for differential calculus. Uh, this is the total points that we can get out of, and this is the dimensions that we are evaluating. The first one is the delivered on time. You can get 5 points if you deliver before on the due date. You get 2 out of 5 points if you deliver your work one day behind, 0 points out of 5 if you are greater than 2 days behind. About the mathematical errors on all your developments, if you are between 90% and 100% of all the steps with no mathematical error, you can get 20 points. If from 50% to 89% of the steps with no mathematical errors, you can get 10 points out of 20. And less than 45, you can 5 points out of 20. In the solutions, if your final solution is correct, 90 to 100% of your problems, then you can get 20 points. If you are between 50 and 89% of the solutions correct, you can get 10 out of 20 points. And if less than 50% of solutions are correct, you can get only 5 points out of 20. Um, we are evaluating the neatness and organization, so it is very important for you to have your work clean, neat, and organized. The proficiency on that is if you present your work in a logic ordered sequence and it's easy to read, you can get 10 points. If your work is presented in a logic order but it's hard to read, 5 out of 10 points. And if your work is sloppy and unorganized, and it's not easy to read, you can get 0 points out of 10 points. About the completeness, you can get 20 points if your problems are 100% complete. Sometimes we skip some steps, so it is very important to have all the development in place so we can see how you were performing your calculations. The partial completeness, around 80%, cuts these points in half, so you can get 10 out of 20. And if less than 70% of your problems are completed, you can get only 5 points out of 20. So if you make the math here, you can have 20, 40, 60, 75% total if your rubric is completed, and this is equal to 100% on your activity. Okay, so this is the rubric that we are going to be applying just as our last period. And about your work, um, it's up to you if you want to send your work in Microsoft Word or in Google Sheets or Google Documents, or if you want to write notes and use handwritten in your notebook. I'm not asking you to have a specific color of ink in your pens. I'm not asking you to write a margin on your sheet of papers because you are big enough to be ordered and do your work with neatness and organization. Okay. Um, I think that's it in matter of how we are going to use, how we are going to grade, and what we are going to be asked for in terms of how do you present your work. Let's start with a brief introduction of this. This is probability statistics. So the role of statistics in the engineering field is mostly to make decisions. Uh, this is a branch of the applied mathematics. Some people say that this is not an exact science, or and some of other people they say that this is an exact science. In my opinion, this is not an exact science, but is the best way to approximate the reality of the real world to our mathematical models. So it's not easy to understand at the beginning, but once you have and you develop the skills in this subject, you will find this useful, especially when you start to work in real world problems, because most of the formulas that you see in the calculus book are not applicable in real world problems. And sometimes from the numbers, you need to make decisions and you need to draw conclusions in the presence of variability. The variability is something that is present in real world all the time. And if you don't know how to deal with it, you are going to be in trouble at the time that you are making a decisions or draw a conclusions for yourself, for your boss, or for your company. So probability statistics is also defined as the science of data because this data is obtained from the experimentation. This data is drawn from the real world phenomena. The real world doesn't match the exact mathematical models all the time. For example, if you observed in your car the gasoline mileage and you are frequently measuring the amount of gas that your car is consuming against any distance, say miles or kilometers or whatever. So if you are observing this gas mileage on your car, the question is this value always fixed? In other words, can I say or can I tell that my car is uh, using or 1 liter every 5 kilometers? Is this value fixed all the time? It is a constant value. If you do your calculations by yourself on your own car, you will find that that's not true. Why? Because, for example, the pressure on the air on your tires will create an effect. If your tires are flat or are low in air pressure, the effect of that is that your car is going to use more gasoline to move. So, from that point, your mileage value is not fixed anymore. If you are driving up to the hill, your car will use more gas than if you are driving down of the hill because there are other factors that are working against or in favor of the gas mileage of your car. So those factors that are not always constant make that the value for gas mileage is not always constant in your car. For example, if you take a look to this little engineering problem, let's say or let's suppose that you as an engineer, you were hired to design an electrical connector to be used in an automotive engine application. You are out of school, you are a graduate, you had hired for, I don't know, by a multinational company, and you are making a lot of money there. And you, as an engineer, you are hired because you need to design electrical connectors to use in the automotive industry. So, when you are working with your design and you establish that a wall thickness of 3/32 of an inch in that connector, you say, okay, let's work with this thickness in the wall of the connector. The wall is the cover of the connector, the part that we can support the connection pins and fit the mate connector, which is the counterpart. So you say, okay, 3/32 of an inch is okay to have for wall thickness, but you are now uncertain because that decision because there is some effect that you are evaluating in the pull of force. If you know when you plug in a connector, there is a force that we apply to get this connection done. Let's say, for example, that we have here, this is the outlet of our home. So this is the 110 volts, and you have this here. So every time that you plug this in, there is some force applied to get this in. And if you apply a force in the opposite way, you can get this disconnected. So this is the pull-off force. So there is some effects on that pull-off force that is making you have adopt about this 33 seconds thickness on the wall for that connector. And you don't want this connector to fail. So let's imagine that you say and you tell your assistant, hey, please produce eight parts, eight prototype parts, and take measurements of that pull of force and see how it looks like. And you go there and you see that the first sample is 20.6, let's say, newtons. Then the second sample is 12.9. The third is 13.4. The fourth is 12.3. The fifth is 13.6, 13.5, 12.6, and 13.1. Why, if you are producing all these connectors with the same wall thickness, why the pull-off force is different from part to part? Well, this is because of the natural variability. In this case, this force value that you are analyzing here, this force becomes a random variable. And one of the most common notations for random variable is the x. This is no longer a constant value, it's a random variable. And the model to represent this is going to be x, which is a random variable, is going to be equal to mu, and mu is the average of these values, some constant value. This is the expected value for all these samples of pull force. And we are adding this little term named epsilon. Why we are adding this epsilon? Well, because this epsilon represents the natural variability of these random variables. And some of these differences from part to part are coming from the measurement system, which this is something that we already covered almost a year ago. And the other part is from the natural variation or variability of the thickness inside each part and other factors that we don't know. So if you can model this with a strict mathematical formula, you're not going to be able to make decisions or draw conclusions about this. Not if you don't know how to handle the variability. Okay. So if you have any questions or comments, please let me know. This is a brief introduction of what probability and statistics is. If something is not clear, please let me know so I can clarify a little bit more for your deep understanding. Stay safe.